Good evening and welcome to our program. Tonight we delve into a question that sparks both fascination and fierce debate. Should humanity make significant financial commitments to space exploration, or are our precious resources better allocated to solving the pressing problems right here on Earth? It's a complex issue balancing future possibilities against present needs. Joining us to argue passionately in favor of substantial investment in space is Dr. Kenji Tanaka, a distinguished astrophysicist whose work focuses on planetary formation and extrasolar planets. Welcome, Dr. Tanaka.
Thank you for having me, Dr. Reed. It's a pleasure.
And presenting the case for prioritizing terrestrial challenges is Ms. Maria Flores, a respected development economist specializing in resource allocation and global inequality. Welcome, Ms. Flores.
Thank you, Dr. Reed. I appreciate the opportunity to discuss this critical matter.
Our format tonight will begin with opening statements from each of our guests, followed by a period of rebuttal and discussion, and finally, closing remarks. Dr. Tanaka, you have the floor first.
Thank you. I believe, fundamentally, that space exploration is not merely a luxury pursuit. It is an essential investment in the future of humanity, our knowledge, and our technological capabilities. Firstly, the scientific advancements driven by space exploration are unparalleled. We gain a fundamental understanding of our universe, our place within it, and indeed our own planet. Studying other planets informs our understanding of Earth's climate and geology. Observing the cosmos gives us a cosmic perspective that is invaluable. Furthermore, planetary science pushes the boundaries of physics, chemistry, and biology, potentially leading us to answer one of the biggest questions. Are we alone? Secondly, space exploration acts as a powerful catalyst for innovation. The extreme challenges of space travel demand novel solutions, leading to technological spin-offs with profound, tangible benefits right here on Earth. Think about satellite communications, the GPS in your phone, advanced weather forecasting, medical imaging techniques like MRI and CAT scans, which built upon space imaging technology, durable materials, even water purification systems used in disaster relief. Many have roots in space programs. These cross-disciplinary applications significantly improve our quality of life and drive economic growth in ways direct. Earth-focused R&D might not anticipate or achieve as rapidly. Thirdly, space exploration inspires. It captures the imagination, encourages young people globally to pursue careers in science, technology, engineering, and mathematics, the very fields crucial for solving future challenges, both on Earth and beyond. Major space missions often become shared endeavors, fostering international collaboration and reminding us of our shared human potential when we aim for ambitious, common goals. Finally, and perhaps most critically, space exploration relates to our long-term survival. Understanding our cosmic neighborhood is vital for planetary defense against potential asteroid impacts. Developing the capacity to operate beyond Earth is a form of existential risk mitigation. While it seems distant, having a long-term vision that includes becoming a multi-planetary species could ultimately be essential for safeguarding the future of consciousness originating from Earth. Therefore, investing significantly in space is not about escaping Earth's problems, but about securing our future, expanding our knowledge, and driving the progress needed to tackle challenges both here and in the cosmos.
Thank you, Dr. Tanaka. Ms. Flores, your opening statement, please.
Thank you, Dr. Reed. Dr. Tanaka paints an inspiring picture, and the intellectual curiosity driving space exploration is certainly understandable. However, I must argue that large-scale investment in space represents a profound misallocation of our finite resources, particularly when measured against the urgent life-and-death crises we face on our own planet. My primary concern is the staggering opportunity cost. The billions, sometimes tens or hundreds of billions, spent on single space missions or programs could have a transformative impact if directed towards fundamental human needs. Consider the cost of the James Webb Space Telescope, roughly $10 billion. Compare that to the estimated annual funding gap to achieve basic sanitation and hygiene globally, or the resources needed to combat preventable diseases that kill millions each year, predominantly children. When we discuss resource allocation, these are the competing priorities we must honestly confront. Are distant discoveries more valuable than saving lives and alleviating immediate suffering now? Secondly, we are confronting pressing global issues that demand our immediate and focused attention. Climate change threatens ecosystems, economies, and lives on an unprecedented scale. Extreme poverty, food insecurity, lack of access to clean water and healthcare persist for vast segments of the global population. These aren't abstract future risks. They are causing immense hardship and instability today. Achieving sustainable development requires massive, concerted investment here on Earth. Diverting significant funds to space exploration seems irresponsible when our planetary home is in such distress. Thirdly, regarding the technological spin-offs Dr. Tanaka mentioned, while some benefits are undeniable, I question the efficiency of this approach. Is investing billions in space, hoping for useful side products, truly the most cost-effective way to develop solutions for earthly problems? Wouldn't direct investment in targeted research, for medical technology, for renewable energy, for water purification, yield faster, more relevant, and cheaper results? The argument that these innovations wouldn't happen otherwise feels speculative. Often, the spin-offs are adaptations of existing research, accelerated perhaps, but not solely dependent on space programs. A thorough cost-effectiveness analysis is often lacking. Finally, there is a profound ethical dimension. Is it morally justifiable to invest colossal sums exploring Mars or distant galaxies, while millions on our own planet lack the basic necessities for a dignified life? Does responsible stewardship not demand that we prioritize the well-being of current inhabitants of Earth over speculative long-term goals in space? This raises serious questions about global inequality and our ethical imperatives. In conclusion, while space exploration holds a certain allure, its immense costs cannot be justified when weighed against the urgent need to address poverty, disease, environmental degradation, and inequality here on Earth. Our focus must be grounded.
Thank you, Ms. Flores. We now move into a period of rebuttal and discussion. Dr. Tanaka, you have the opportunity to respond to Ms. Flores' points.
Thank you. Ms. Flores raises important points about resource allocation, but I believe the perspective needs adjustment. Firstly, the quote, staggering costs she mentions need context. Global space exploration budgets, while substantial in absolute terms, are often a tiny fraction of global GDP or, more pointedly, global military expenditures. Redirecting even a small percentage of military spending could dwarf current space budgets and address many of the issues Ms. Flores rightly highlights. So framing this as a simple choice between space and humanitarian aid is a false dichotomy. We can and should pursue both. The investment in space yields high returns, not just scientifically, but technologically, feeding back into our ability to solve earthly problems. Regarding the focus on immediate needs versus long-term vision, neglecting the future for the present is short-sighted and ultimately dangerous. Scientific progress, driven significantly by ambitious goals like space exploration, underpins our ability to tackle future crises, including those Ms. Flores mentioned, like climate change. Earth observation satellites, crucial for monitoring climate change, are a direct product of space investment. Understanding planetary atmospheres helps refine our own climate models. It's not an either-or situation, it's interconnected. On the efficiency of spin-offs, Ms. Flores suggests direct R&D is always better. But the unique extreme requirements of space, reliability, miniaturization, operating in hostile environments, force innovations that might not occur in conventional R&D settings. Consider materials science, advanced robotics, or life support systems. These fields have been dramatically advanced by space programs, creating technologies now indispensable on Earth. It's not just about hoping for side products. It's about pushing technological frontiers in a way that has broad, often unpredictable benefits. Finally, the intangible benefits, inspiration, education, international cooperation, should not be dismissed. They foster a scientifically literate populace and collaborative spirit essential for tackling global challenges together. Investing in hope and human potential is also a vital investment.
Thank you, Dr. Tanaka. Ms. Flores, your rebuttal?
Dr. Tanaka's comparison with military spending is a common deflection, but it doesn't negate the core issue. Just because vast sums are potentially wasted elsewhere doesn't justify spending billions on space exploration, when those same billions could be demonstrably used to save lives and improve immediate conditions through targeted aid or development programs. The absolute monetary value dedicated to space remains enormous, and its potential impact, if redirected to specific, underfunded terrestrial programs, like vaccine distribution or clean energy access in developing nations, is undeniable and far more direct. While I acknowledge the value of Earth observation satellites, these represent a specific, applied use of space technology, directly benefiting Earth management. This is quite different from multi-billion-dollar missions to Mars or the outer solar system, whose direct relevance to immediate crises is far more tenuous. Dr. Tanaka speaks of long-term vision, but the urgency of the climate crisis, for instance, demands immediate, large-scale action now. If we fail to address this terrestrial threat within the next decade or two, the quote, long-term future he envisions, potentially on other planets, becomes a moot point for the vast majority of humanity left behind on a damaged Earth. This isn't about neglecting the future, it's about ensuring we have a viable future to reach. Prioritization based on urgency is crucial. Regarding spin-off efficiency, the argument that space provides unique pressure for innovation remains questionable from a cost-benefit perspective. Could the specific advancements in medical imaging or water purification have been achieved more rapidly and cheaply if the funding initially allocated to space had been directly channeled into medical or environmental engineering research? I suspect in many cases the answer is yes. We need more rigorous analysis comparing direct investment pathways versus the indirect, uncertain route of space spin-offs. And the ethical argument remains central. Inspiration is valuable, but is it ethically defensible to spend fortunes reaching for the stars while millions endure preventable suffering? For me, the moral weight of present human need must take precedence over the admittedly fascinating but ultimately less critical quest for cosmic discovery.
Let's facilitate some direct exchange now. Ms. Flores, you mentioned the value of Earth observation satellites. Are there other space activities you might see as justifiable uses of resources, perhaps in planetary defense against asteroids, which Dr. Tanaka raised?
That's a fair question. Earth observation for climate monitoring, disaster management, and resource tracking clearly offers direct, tangible benefits for managing our planet. Investment there is justifiable. Planetary defense against existential threats like asteroids also falls into a different category. Modest, targeted investment in detection and potentially mitigation strategies could be seen as a reasonable form of global insurance, provided it's proportionate and doesn't detract massively from other urgent needs. My core objection remains with the extremely high-cost, blue-sky exploration missions, sending probes to distant planets, or ambitious crewed missions beyond Earth orbit, whose immediate relevance and cost-effectiveness are questionable compared to terrestrial priorities.
Dr. Tanaka, Ms. Flores emphasizes the difficulty in seeing the direct relevance of major exploration missions compared to, say, funding clean water projects. How can space agencies and proponents of exploration better demonstrate or even enhance the direct, near-term benefits of their work to those concerned about immediate Earthbound problems?
That's a crucial point. Communication is key. Space agencies need to be far more proactive and effective in highlighting the practical applications and spin-offs derived from their work, connecting the dots clearly for the public and policymakers. This means moving beyond abstract scientific discovery and showcasing how space technology improves weather forecasts, enables global communication, advances medical devices, or creates new materials used in everyday life and industry. Furthermore, perhaps there could be a greater emphasis within space programs themselves on accelerating the transfer of technology for terrestrial applications. Maybe specific funding streams could be dedicated to adapting space-derived innovations for humanitarian or environmental purposes. It's also about framing exploration not as an alternative to solving Earth's problems, but as a complementary activity that expands our toolkit and perspective, ultimately helping us manage our own planet better while also looking towards the future.
Ms. Flores, even with better communication or efforts to transfer technology, does the sheer scale of funding required for something like a crewed mission to Mars still present an insurmountable ethical or practical barrier for you, given current global needs?
Yes, frankly, it does. While improved communication and tech transfer are welcome, the fundamental issue of scale persists. A crewed Mars mission, projected to cost hundreds of billions, possibly trillions over its lifetime, represents an investment so vast that it inevitably diverts resources and focus from immediate, critical needs. No amount of spin-off potential, in my view, can ethically justify that level of expenditure, while basic human security, from hunger, disease, climate impacts, remains unmet for billions. It reflects skewed priorities, perhaps far in the future, when we have adequately addressed Earth's major challenges. Such ambitious projects might be reconsidered. But under current circumstances, it feels profoundly premature and ethically questionable.
Dr. Tanaka, a final thought on that perspective before we move to closing statements. Is there a risk that always prioritizing the immediate prevents humanity from ever taking the bold steps needed for long-term advancement and security?
There is absolutely that risk. History shows that societies which cease to explore, to push boundaries, and to invest in fundamental knowledge eventually stagnate. While addressing immediate needs is vital, solely focusing on the present at the expense of investing in future capabilities and knowledge is a recipe for long-term decline. Bold steps, like aiming for Mars, drive innovation across the board in ways that incremental, safety-first approaches often don't. It's about balancing responsibilities, managing the present effectively, while simultaneously investing strategically in our capacity to navigate the future, whatever it may hold. It's not an either-or, it's a necessary balance.
Thank you both. We now turn to closing statements. Dr. Tanaka, please summarize your position.
Certainly. Significant investment in space exploration is an investment in humanity's future. It drives fundamental scientific discovery, yields crucial technological advancements with broad applications on Earth, and inspires global collaboration and the next generation of innovators. It provides a necessary long-term perspective, helping us understand our own planet better and potentially safeguarding our species against existential risks. While addressing immediate needs is crucial, abandoning our drive to explore and understand the universe would be a profound mistake, limiting our potential and our resilience. Investing in space is investing in progress.
Thank you, Dr. Tanaka. Ms. Flores, your closing statement.
My position remains clear. While intellectually stimulating, large-scale space exploration represents an unjustifiable expenditure given the urgent and profound challenges we face here on Earth. The immense opportunity cost, the lives that could be saved, the suffering alleviated, the environmental damage mitigated with those same funds is simply too high. Direct investment in solving terrestrial problems is more efficient and ethically imperative than relying on uncertain technological spin-offs from costly space ventures. Responsible stewardship demands that we prioritize the immediate well-being of humanity and the health of our planet. We must focus our resources and ingenuity on solving the crises at hand, before embarking on grand, expensive journeys outwards.
Thank you, Ms. Flores, and thank you, Dr. Tanaka, for a compelling and thought-provoking discussion on this complex issue. Tonight's debate underscores the difficult choices humanity faces in balancing our aspirations for the future with the pressing needs of the present.